today we're going to look at section 5.2, which is all about right triangle trig. So our objective today is use right triangle trig to solve applied problems. This section should hopefully be more of a review than anything else. This is something that you should have done in geometry last year during that short trig unit. So let's review. Solving right triangles using trig. Okay, finding all missing side lengths and angle measures of a right triangle is called solving a right triangle. So there's a couple of things that we need to remember when doing this. We need to remember that the two acute angles have to add up to 90 because remember, three angles of a triangle add up to 180. And if we're talking about right triangles, one of the angles is already 90, so 180 minus 90 is why there's 90 degrees left over for the other two angles. We also have to remember, and we've practiced this before, but to find the measures of these acute angles, you have to use the inverse button on the calculator. So remember, you have to do like second sine or second cosine so you can get that little inverse button in order to calculate angles. And then when we're doing our angles, we're always going to round to the nearest whole number unless it's told to us to do otherwise. And as far as the lengths of sides, we'll do whatever it's stated in the directions. Sometimes it'll say to the nearest tenth, which is 1 decimal place. Sometimes it might say to the nearest hundredth, which is 2 decimal places. So just read very carefully so we know what we have to round to. All right, so we are going to find missing sides and angles of this triangle ABC. We'll round the sides to the nearest hundredths. So remember, that means 2 decimal places. Okay, also notice that in this problem, we're talking about degrees. Okay, we're dealing with 90-degree angles, and in this case, I'm giving you a 62-degree angle. So you have to absolutely check your mode on your calculator. We want to make sure that when we go to mode, that we are in degree mode. Okay, radian mode is going to mess us all up. So make sure you are in degree mode in your calculator. So once again, if I want to find all the missing sides and angles, well, let's just talk about the fact that if it's a triangle, there's 3 angles and there's 3 sides. So I'm just going to write angle A, angle B, angle C, and then I'm going to write sides. And so understand that we'll have like little a, little b, and little c, and those sides are going to be across from the angle. So notice that angle A, the side across from it, that's the side A. So notice that like across from angle C is side C, across from angle B is side B. Okay, so we can already fill in, we should always be able to fill in 3 things automatically. So in this picture, I know that angle C is the 90-degree angle. We're told that angle B is 62 degrees, and we know that side A is 6. Okay, so you should always have 3 things. We're trying to find the 3 missing pieces. So like I mentioned in the other slide, remember, 3 angles of a triangle add up to 180, or in this case, the 2 acute angles are going to add up to 90 because the third angle is 90. So because I gave you angle B, to find angle A, we just have to subtract 62 from 90. And so that's going to give us angle A right away to be 28 degrees. So that shouldn't be the hard part. So now we just have 2 sides to find. And since we only give you one side of the triangle, it's not like we can do Pythagorean theorem. We're going to have to use some trig. So we want to think about SOHCAHTOA and figure out which one of those 3 trig ratios is going to benefit us the most. So let's find side B. Okay, so notice that if I want to deal with side B, you can deal with either acute angle. I think I'm going to deal with the 62-degree angle just because that's what was given to me. So notice that B is across or opposite from it. So I know it's going to be either sine or tangent. But then the only other side we know is a leg. So that means that if I'm dealing with the 2 legs, we're dealing with tangent. So I'm going to set it up as the tangent of 62 degrees is going to equal the opposite side, so B, over the adjacent side, which is 6. So in order to find B, I need to get rid of that division. So to divide by 6, the opposite is to multiply by 6. So then luckily for us, that gets us the b by itself. Your calculator should be in degree mode. We just have to type it exactly how we see it. 6 times the tangent of 62. Once again, the directions say to round to the nearest hundredth, so 2 decimal places. So it looks like side B is going to be 11.28. Okay, then if I want to find side C, we are not doing Pythagorean theorem because we already have a rounded number for side B. I want to be as exact as possible and just round at the very end. So that means we have to go back and think about trig. So because C is the hypotenuse, we're using either sine or cosine. And so once again, it really just depends on what acute angle you want to use. I think I'm going to stick with the 62-degree angle. So that means that the side that's given to us that isn't rounded is 6. That's adjacent to that. So adjacent and hypotenuse means I'm going to talk about cosine. So the cosine of 62 degrees is going to be 6 because that's adjacent over the hypotenuse, so C. So now I want to start solving for C. Once again, I got to get rid of the division. So I need to multiply both sides by C to get rid of that fraction. But then that doesn't get you C by itself. C is being multiplied by the cosine. So to undo multiplication, I'm going to divide both sides by the cosine of 62 degrees. So this is what we want to type in our calculator, 6 divided by the cosine of 62 degrees. And so this should be the longest side because the hypotenuse is always the longest in a right triangle. Rounding to 2 decimal places because that's what it means when we're talking about hundredths. I got 12.78. So everything checks out. Here are all of the pieces of that right triangle. We are done with the problem. Okay, let's try another one. I want to find the missing sides and the angles. Once again, it's triangle ABC. So we've got angle A, angle B, angle C, side A, side B, and side C. So notice that in this problem, the only angle that they gave us is the right angle, which once again is angle C. We don't know what side A is. Notice that side B is across from angle B. So side B is 40. Side C is across from angle C, so that's 41. So we've got 3 pieces. We're trying to find 3 more. I think I'm going to start with the sides because I have 2 out of the 3 sides. This does allow us to do Pythagorean theorem. So a squared plus b squared equals c squared. This is technically a Pythagorean triple, but it's one of the lesser unknown ones. So if you maybe remember it, then you don't necessarily have to do Pythagorean theorem, but I'm just going to walk us through it. Okay, 40 squared is going to be 1600. 41 squared is going to be 1681. Got to start solving for the a, so I'm going to subtract the 1600. That gives me then a squared to equal 81. To get rid of a square, we take the square root. Normally we have 2 answers, but because we're talking about the length of the side of a triangle, square root of 81 will just take the positive, so 9. Okay, so remember that is one of our triples, but it's one of the lesser unknown ones. So just to kind of remember the other triples, we've got like 3, 4, 5 families. We've got 5, 12, 13. 8, 15, 17. We have 7, 24, 25. Hopefully these numbers are kind of looking familiar from geometry last year. These were the main triples that you probably are familiar with, but 9, 40, 41 is technically another one. All right, so now let's talk about how do we find the angles. Once again, I want them in degrees because we have a 90-degree angle here, so your mode should still be in degrees. Doesn't matter which angle we find first. I think I'm just going to find angle A. So to find angle A, I want to look at the sides that are given to me. Technically, 9 is a nice number, so you could use that, but I think I'm just going to stick with the 40 and the 41. 40 is adjacent to the angle that I want to find, and 41 is the hypotenuse. So once again, if you think about SOHCAHTOA, adjacent and hypotenuse would be cosine. So cosine of angle A is going to be 40 divided by 41. So remember, when you're typing it into the calculator, you have to do second cosine so we can get the inverse. And then I want 40 divided by 41. I want to round to the nearest whole number. So because it says 12.68 and so on and so forth, that means I'm going to round it up. So it looks like angle A is a 13-degree angle. Okay, and once I found one of the angles, to find the measure of angle B, I can just do the fact that those two acute angles have to add up to 90. So they're complementary. So I just have to subtract and I get 77 degrees. If you wanted, you could do another trig equation, but it's really not necessary. So here are the answers to this problem. All right, and then we've got application problems. So remember, terminology is going to be important to remember. We've got two phrases, angle of elevation and angle of depression. Okay, so many applications of right triangle trig involve the angle made with an imaginary horizontal line. So the angle formed by a horizontal line and the line of sight. So if a person is looking straight ahead from that horizontal line, if they start looking up, we call that angle then the angle of elevation because you're moving your eyes from straight ahead upwards. So you're elevating those eyes. The second one would be angle of depression. That's when you look straight ahead and then you start lowering your eyes. When you lower your eyes, you're looking below. That's the angle of depression. Okay. So when you're thinking about setting up triangles, that means that your triangle for angle of elevation is always going to be on the bottom of the triangle, inside the triangle, and angle of depression is technically then outside the triangle up at the top. All right, so let's take a look at a couple of application problems. So it says the irregular blue shape represents a lake. The distance across the lake, A, is unknown. To find the distance, a surveyor took the measurements shown in the figure. What is the distance across the lake to the nearest yard? Okay, so this one doesn't really necessarily use the phrase angle of elevation, but because that angle 24 degrees is inside of the triangle and it's down being formed with the bottom, this is technically an angle of elevation problem. So if I'm just thinking SOHCAHTOA, notice that the side that I want to find is opposite. The side that's given is the adjacent. So that means we're using tangent here. So tangent of 24 degrees is going to equal A, because that's an opposite, over 750, because that is adjacent. So the only thing we have to do to get the A by itself is to multiply both sides by 750. Once again, your calculator is going to be in degree mode. We're not switching it back and forth between degrees and radians. And then I can just type this in exactly how I see it. It says to round to the nearest yard, so make sure you're reading directions carefully. Even though it's a side, the nearest yard means no decimal. So that looks like, because it's 333.9, I want to round it up to 334, but then let's put our units, we're talking yards. And that is my answer. But once again, this is technically the angle of elevation here, because you're looking straight ahead from A to C, and then you had to elevate your eyes up to get to B. All right, let's take a look at another one. It says the Washington Monument is 555 feet high. If you're standing 1/4 of a mile or 1320 feet from the base of the monument and are looking at the top, find the angle of elevation to the nearest degree. Okay, once again, notice that they have the picture sketched for us, but angle of elevation is that angle that is on inside the triangle down at the bottom. And the other thing is noticing that originally they told you a mile, but then they converted it into feet because we were given feet for the height of the monument. You always want to make sure you have the same units when you are doing these types of problems. So luckily the problem already converted it for us. So this time we want to find the angle. So we still have to figure out what trig function we want because 555 is across, that's the opposite. 1320 is adjacent. So we are using tangent again, but it's tangent of theta to equal 555 over 1320. So remember, when we're typing it into the calculator, because I'm trying to find the angle, we have to use second tangent. And then I'm dividing. And once again, it says to round to the nearest degree, so no decimals. So I'm seeing in my calculator 22.8, which is why then my theta, when I round it to the nearest degree, is going to be a 23-degree angle. Okay, so once again, angle of elevation is down there. If they have been talking about the angle of depression in the picture, your angle of depression is up here. But angle of depression and angle of elevation are actually congruent to each other. So if you remember back to the fact that technically these lines of sights are parallel lines, those are alternate interior angles that are congruent. So don't let that thought forget you, okay? All right, pause the video, try this. It says a road inclined at an angle of 5 degrees after driving 5,000 feet along the road. Find the driver's increase in altitude, round to the nearest foot. Okay, so hopefully you understood that we were given the angle, we were trying to find the opposite side, we were given the hypotenuse, so we'd use sine this time. And once again, we're in degree mode, but there's no need to hit that second button because I was giving you the angle. Rounding to the nearest foot, 436 feet. Okay, so that's us using right triangle trig to solve applied problems.